So, introduction to drone data and analysis. So, what is the table or the content? Principles of observation or principles of how you capture the images and what images would be the elements of image and video interpretation. Then introduction to photogrammetry. Then types of image and video data and analysis. Okay, so I will give you some examples around each images and each type of data what has been captured. Okay, the principles of observation is basically recognizing the target is the key to interpretation and information extractions. Like earlier in earlier days, before digital technology was available, people used to actually capture. Like for example, let me give an example with respect to the power line towers. Before our introduction to power line towers using drone technology, the traditionally the board used to send people with DSLR cameras and binoculars, okay, to those locations, remote locations. The person used to go to that location from the ground. He used to using little bit zoom lens and whatever available. Using those zoom lenses, they used to uh, capture the images. But again, those images from the ground with the perspective of the ground, from what angle he's trying to capture, and he's not going to capture as many images, right? Whatever possible hai, usko lag raha hai, whatever, that is what he used to capture. Okay, but that data was very random, very inaccurate, not really helpful sometimes. Just I mean they are doing just for sake of doing the activity sometimes. Binocular से वो लोग observe करने की कोशिश करते थे, like whether any damage, any breakage, any power issue is there and all that. So this was very manual, traditional way of doing things. But later on, once you have those images also, they used to come back, they used to process, they have to print those images and try to interpret from these images. Just a minute, I need to take a call. Okay. So basically, they used to do very traditional print photographs and all the things, or they used to monitor. So this was not very accurate and all the things. But they used to implement, magnifying lens like okay, image because you cannot physical print up zoom nahi kar sakte ho, right? So they are trying to find using those and all the things. But because of advancement of digital technology and all the things, people were able to. But again, subject to what kind of data you have captured, how you have captured data. Again, the way they were using DSLR, using digital images and all that things, still they were not having the right images, or amount of images was not that huge also to them, and then they were not able to interpret lot many issues. Okay, and that is why they thought that the okay, drone might be useful in this segment, which will be used because outside other location, other countries, US, European countries and all those, they were already started using drones for this kind of applications, and that's why we also thought that okay, the drones will be very very useful in power line transmission. So once we start capturing those images and everything, when we started looking that, as I said earlier, we were actually capturing first 10 to 12 towers when we did, it was all manual. So we used to send a pilot with the drone, he used to fly the drone, he used to capture images and all. So we used to capture around 100, 200, sometimes even 300 photographs, random photos used to capture, used to click. Okay, so we were having 3 pilots every day. They used to go to different in a day. They used to do it almost like 3, 4, 5 towers in a day. Okay, to capture and images. And then when we used to get that data after end of the day, they used to come back, or probably a couple of days they used to come back. They used to dump all the data into the common storage, and we used, our other team who are supposed to work on those images, on those video footages and also, and then find out the issues in those power line towers. Their power line tower board people also were sitting with us, and we were trying to see and understand what are the problems visible. Like, there is a tower, there is a number plate, there is a danger plate, there is a barbed wire connected, there are supporting member bars for that particular towers. Then there could be bird nest, monkey houses are would be there, or there could be some issues would be there, nut bolt missing, okay, or bolt missing kind of things are there, or there could be possibility the wire would have gone oxidized. The insulator couplings are there which could have got damaged or burned out due to short circuit or friction or all that things, or sparking ho jata hai. So that time those insulator also get damaged and all those things. So all these were observations. So like that, after discussion, after seeing the images and understanding what we have to find and all that things, we understood these are the problems. But then lot of time we didn't have a right images, proper images, and then we saw that all these pilots are flying drones on their own way, and then we had that problem, that our first one drone got bad. Okay, so we thought, okay, it might have gone bad because of something. That time we didn't took seriously. We actually got to know about this magnetic effect, electromagnetic radiation effect, only after our second drone gone faulty. Okay, so that's time we started. But first हमने cordially ignore कर दिया. Okay, चलो ठीक है, हो गया रहेगा, something would have happened and thing. We said, oh, leave it. We'll use, continue using it. जब second drone faulty हो गया, then we thought we took it seriously, and then we started investigating it. What is the problem? That's where we came to know that it's a electromagnetic radiation के वजह से these drones have gone faulty. So then we said, okay, and then we understood that the way the pilots are flying, every pilot will have his own way of flying the drones. Everybody will, like how we drive the car, everybody has their own way of driving the car. Similarly, when you're flying drone manually, everybody has their own way. The control on the drone, all that things will vary. Okay, image what you are capturing, the type of image what you are capturing, all that things will differ. So we said this is not going to help us if you are going to do more number of drones, more number of power line towers. So you are talking about in POC, we are only talking about what say 100 towers. Okay, but actually we had almost, the project was almost of 21,000 kilometers of power lines. Okay, so huge number of towers, almost I think somewhere around 10 to 12,000 towers were supposed to be monitored, okay, in entire BR location. So which was very, very challenging, okay, because there are some lot of locations which will be remote, and reaching those places, capturing these images and all this thing, there would not be a place to stay and all that. So you have to finish the day job in the daytime and come back to the main city or main location and all the things you used to do. Okay, sometimes even people were not aware ये क्या कर रहे हैं, people reported to police also. हमारे एक दो पायलट के लिए उन्होंने वो पकड़ के ले लिया, they caught hold of them. Then they have to call back, they have to give a call from the power board team and tell them that this is the work happening because of the power board team and all that things, and then so that's how they are released. तो वो drone fly कर रहे थे, people को लगा, local people को लगा कि there is something happening, some people are trying to do something around the tower and this and that and all. तो ऐसे भी scenarios आ गए थे. Okay, so coming back to topic, we saw that when pilot was flying the drones, they were flying on their own way. The way they are capturing data is very different way. Some was capturing proper, some was capturing 100, 200 photos, some was capturing only 100 photos, 150 photos. So there is no uniformity in data capturing also. That is where we thought, okay, this is not way we need to do. And then we tried to explore if there is anything which can be done in this. We tried to find out, but there was nothing available at that point in time. Even today, there is not much of the research or application available to do such kind of activities are there. So we got one of the software vendor who helped us to design a flight plan, because most of the flight plans of the drones were all horizontal. You can fly like this. But here the application is altogether different. You are flying in vertical directions. Okay, you are going up and capturing. So your whole path is vertical, up and down. So you don't have any plan designed for such kind of application. So we have to get a vendor who can customize for this kind of activity for us and plan something like that. So we got that person to, the vendor to do all that activity for us, design a flight plan for the, because there has to be some coding has to be done and all that things. So they got it done for us, and then we start flying the drone. So our pilot now, it has eased the work of the pilot, in fact. Okay, so he just have to go to the drone, go to the power line tower near. He just have to see what is the distance, and from that base distance, he has to make capture how far the drone has to be set up and all that things. He will feed that data into the automation software, and the drone will fly on its own. He just have to start. He says start. So from one side it will start, it will keep on capturing the images, then it will go up at the top, then it will come down, start coming down, capturing the images, then the third side and the fourth side. So like this, it used to uniformly captures with what we say, every 2 seconds or 5 seconds, whatever we define the way out the images what we want, it will keep on capturing the images. Tuck, 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 tuck. So we can really actually stitch those images and create a 3D model of that particular tower also using the software. Okay, so 3D में हम लोग पूरा desk पे बैठ के we can see that without physically going near to the tower, that tower was visible in front of us in the office to see all the angles, and then we can zoom every component. That is what level of data what we captured. Then we had a video footages. So when video was captured, it starts and it goes on all directions, circling around the tower like this till the top, and then top it will go and then it will come down. That way how it will capture all the images. So that way the uniformity was there in the data capturing. Okay. So I forgot. Observe the difference between the target and their background involves comparing different target based on any or all of the visual elements. Elements what could be there in the images? It could be tone, shape, size, pattern, texture, shadow, and association with the image. Okay, so these are all important elements of the particular image. When you are interpreting the image, you need to see whether there is what kind of tone, what kind of shape, what kind of size, is there any pattern, is there any texture, is there any shadow which is helpful to understand the size of the object, and if there is any association with respect to the image. Okay, so tone refers to the relative brightness or color of the object in image. Generally, tone is a fundamental element for the distinguishing between different targets or features. Variation in tone also allows elements of shape, texture, and pattern of object to be distinct. So tone basically gives you an idea. Like for example, if you see this image, different field will give you different tone of image. Okay, this might be a ready-made field, or this field would be there. This could be a barren land. Then you see there are bushes which have been planted here. This might be some kind of a playground. There might be some trees over here. All that thing. You can see the road clearly. So you can distinguish between different tones of the color what is been shown. If this would be color image, then it will be more effective. We purposely have this black and white because we want to show you in a grayscale. Okay, how to interpret. Okay, now shape. Shape refers to the general form, structure, or outline of an individual object. Shape can be very distinctive clue for interpretation. Straight edge shape represent urban or agriculture field target, while the natural features such as forest edges are generally more irregular in shape, except where the man has created a road or a clear cuts. Farms or crop land irrigated by rotating sprinkler would appear as a circular shape. So you can see here there are certain ground has been created over here. Okay, some recreational activities there. You can see the road which is there. There is the empty land is there. Okay, some land with the house and all the structures you can see based on the shapes. Okay, whatever you see in the image. Pattern, again pattern refer to special, like similar type. Like if you have seen image of a Barcelona city, have you seen any time a Barcelona city image? Spain में एक city है Barcelona, right? Famous footballers.
Yes.
So Barcelona city is a very structured. Like if you take a aerial view of that city, you will see whole buildings are in a very structured pattern way, right? So similarly, if the spatial arrangement of the visible distinct object, typically orderly repetition of similar tones or texture will produce a distinctive and ultimately recognizable pattern. Like if this is a orchard field, okay, with evenly spaced trees, or urban streets with regularly spaced houses, are good examples of patterns. Like अगर आप कॉलोनी देखोगे या सिमिलर टाइप्स ऑफ रो हाउसेस है और उसका फोटोज लेते हो तो देन यू विल हैव अ सिमिलर टाइप ऑफ पैटर्न्स यू कैन ऑब्जर्व। और जैसे मैंगो का प्लांटेशन है या चीकू का प्लांटेशन है, वहां पे अगर आप फोटोग्राफ्स करते हो और एरियल व्यूज फोटोग्राफ करते हो तो यू विल सी सिमिलर स्ट्रक्चर, सिमिलर वे द थिंग्स आर देयर। Okay, size of an object is an image function to scale. So depending upon, like you can see here, there are small houses on the right sides here, whereas there is a one big warehouse structure over here, you can see. Okay, so that is what this could be, the office and all the things. This could be some recreational activity, or maybe some small store could be there, or this can be a very big factory where huge machineries would have been set up, and then people who are working in this particular factory, the people would be staying near to the factory area only. So that is how it could be, we can interpret from this particular image. So every image will have its own story, its own way to interpret. Texture refers to arrangement of frequency or tonal variation in particular area of image. Rough textures would consist of molted tone where the gray level changes abruptly in small area, whereas smooth textures would have a very little tonal variation. Like if you see here, there is no variation here. If you, this is an empty barren land. This is actually a forest. Okay, this is all forest. You can see little bit grassy land on the top. This could be the forest. This could be the empty barren land where there is no changes. Okay, this is a very similar structure. You can see the color pattern is almost similar over here, but where here you can see different texture is there with the trees appearing over here. Okay. Shadow is also helpful in interpretation as many provides an ideal of the profile and relative height of a target. So if you see this, depending upon what time you are capturing the image, like when we were capturing the power line towers images, when we are capturing in a daytime, in the early morning time, normally our pilot used to visit the sites around 7 a.m. Okay, because sunrise used to happen around 6:30. So 7 a.m. they will start flying around those towers, and because they are supposed to complete minimum 5 towers in a day. Okay, so it's a very lengthy timelines. So morning 6 baje, 7 baje se they used to start till evening 5, 6. They used to till the sunset. So sunrise to sunset they used to take the photographs, videos and all that things. So they were supposed to complete minimum 5 towers initially. Okay, so when they were doing physically, as I told you, they were able to do 4 to 5 towers, because in a 1 kilometer range there were only 3 to 4 towers out there. Okay, so it takes time, because you have to fly the drone, down the drone, remove the chip, transfer the images. Sometimes you have to do all those things. Okay, later on we upgraded, because by default in a drone it was having 2 GB of cards. So later on we upgraded those to 8 GB, 16 GB, so that we don't require to remove the card for making the memory space. Okay, for capturing the images and video, because normally when we were flying the drones we were actually capturing, initially we were capturing around 100, 200, 300 photographs, but when we went into the autonomous mode we were able to capture almost 500 to 700 photos. Okay, videos what we used to capture was initially of 1 GB, 2 GB kind of thing. Later on it went to up to 5 GB of video size of data. So we need a huge capacity to store and all those things. So what time consuming hota tha if you want to change the battery, change the power, memory card and all the things. So we have to effectively remove. We also had to purchase multiple battery sets also that point in time, because earlier we were only carrying 3 sets of batteries. तो हमारा बैटरी तो 15 मिनट का फ्लाइट टाइम है, 15-20 मिनट का फ्लाइट टाइम होने का, फ्लाई करके होता था, चार्जिंग करने के लिए 1 घंटा लगता था, 1-2 घंटा लगता था. ओके, 3 hours sometimes depending upon what battery cycle and what battery I am using. So that was time consuming. We are wasting time over there. फिर बाद में जैसे बैटरी आपके डिस्चार्ज हो गए तीनों, चार्ज होने के लिए आपको 2 घंटा लगने वाला, तो पायलट वाज नॉट दैट टाइम, ही जस्ट यूज्ड टू कॉपी द डेटा इनटू हिज लैपटॉप. इट हार्डली 10 minutes 15 minutes लगता था उसको, but rest of the time he was sitting idle, he was doing nothing. So to improve that, that's why we were not able to complete 4 to 5 towers also in a day. Okay, that's why it is, because all these logistic challenges were there. So we understood these problems are there, and then we procure more number of batteries, like 3 के जगह पे 6 बैटरी यूज कर रहे हैं, कहीं पे 8 बैटरी 10 बैटरीज also we have utilized on drones. So we made all those changes to improve our day-to-day work, improve the capturing of the data and all this. But later on, when we were actually using autonomous feature for capturing, my capturing was almost reached to almost 12 to 15 towers in a day. Okay, so we were approximately 10, 12, 15 towers maximum. 15 towers we were able to complete in a day. Okay, because that how the efficiency has improved in our day-to-day work by doing these small changes, like adding more number of batteries, changing the way I am capturing the images. You know, earlier manual mode से हम लोग autonomous mode पे गया. So dependency of the pilot also got reduced. Pilot is only monitoring, seeing, setting up the parameters for flying and all the things, and then he just fly. He just doesn't have to worry. Drone will automatically fly, capture the images, and land at the RTL location. That is how we have configured the flight plan. So that was done. So it was so simple and so easier. So your work was more effectively. Your pilot was utilized for more time, and we were able to capture more data. Like you know, पहले जो 100, 200, 500 photos होते थे, now we got 700 photos and good photos, similar type of photos, good way the photos have been captured. So it was very easy for to stacking them in a software. Okay, and then we can create really a 3D model of a power line tower in front of us. Okay, so we can rotate in all 360 degrees and see the tower practically in front of us. If we would have a technology of like holographic image or something like that, we would able to actually reconstruct a 3D image of that particular tower. That much amount of data we would have it. That is what we actually thinking about that time. Okay, like I mean, I just one day I spoke to the stakeholders of Power Board that this is what actually I was thinking about it. Then he was to ask me, can you explore whether is it? But I tried to explore, but I could not find much already because those holographic projections and all the things are very expensive, and right now that technology has not evolved so much. But maybe down the line future, maybe another 5, 10 years, you know, right now there are a lot of research is going on holographic projections and images and everything. Probably maybe down the line 5 years, 10 years, you may see those kind of applications coming in. Okay, association takes into account the relationship between the other recognizable objects or feature in the proximity to the target of interest. The identification of the feature that one would expect to associate with other features may provide information to facilitate identification. In the example given here, if you see the example given here, the commercial properties may be associated with the proximity to the major transport route. You can see there are little bit shops or maybe commercial things would be there. Okay, and then whereas the residential area would be associated with the playground. So there could be some residential areas, there could be playgrounds, and in this particular example you can see this is a lake actually. Okay, this is a lake associated with boats and marine and recreational land over here. So depending upon each image will have its own association with the main image, okay, or the object in the image. Depending on that, we can interpret based on what image it is. Like a lot of time we used to take a long view or a wide view of the photograph of power line tower. So we need to capture those images also to refer to know this particular tower belongs to which location or which area. So we have to capture the background image, not the closer image, but we have to take the drone little bit away, almost like 50 meters away from the tower, 50 or 100 meters away from the tower, and capture that image of the tower from all the 4 directions. तो वो भी हमको करना पड़ता था because we need to associate and know, understand this where this particular tower is located, in which area, which location, how that location looks, what is there are other objects near the tower. Okay, कभी कभी कोई टावर के आजू बाजू बिल्डिंग होता था, हाउस होता था, we need to know all those things. That association was also required over there. So used to capture those wild field view of images also to get the association of that particular tower also. Okay, types of image and video data. So you can we have already seen in the payload, right? RGB के images capture कर सकते हो, infrared के images कर सकते हो, near infrared, night vision, thermal images, multi-spectral images. All these types of images you can capture using different payloads. So you can see infrared images there. Then you can have near infrared images there. Okay. Then you can see thermal images can be also captured. Then you can see multi-spectral images, like you can see here. Basically normal RGB में आपको images you might see something like this, but in multi-spectral interpretation you can make out the difference in the land. Like see, this green land will look exactly like this green, but this barren land I cannot understand what is it exactly. So here the color will tell me what is the value. So if you see this red is 0.0035 NDV value, okay, or if you see this particular area of a land, okay, entire land is yellow and green. So you can, based on the NDV value, I can make sure that my crop is good. But at certain location, I can see there are some patterns, right? Some red and all the things. So if I zoom this particular location, I can see there are some red and this thing. So here the NDV value. So based on what value and for what purpose that value has been defined, maybe the crop has not grown at this particular location, or might be this crop has become bad, or some issue is there with related to that crop at that particular location. That is how I can interpret. But अगर मैं normal देखो अभी जैसे if you see this particular image, here I cannot really make out, or here if you see wherever there is a green, I cannot really make out anything out of it. But when I have defined the multispectral image, in different spectral it will give me different colors. Okay, so basically based on that I was able to interpret there is some issue. Like even if you see there are some red spots over here, okay, at the edges or something, so I can make out what is the challenges at that particular location by using multispectral images. Night vision, again this is military applications or very high-end applications where night visions can be used for interpreting what data and all this. Maybe mostly in military or missions, but normally they will use this kind of payload or capture such images. Okay, then introduction to photogrammetry. Photogrammetry, as I said, it is not that today we are using. Okay, only because of digital evolution, photogrammetry has evolved much better way than what it was earlier. But there was photogrammetry was earlier. People used to print the photographs, use the magnifying glass, and they used to do that photogrammetry manually. Photogrammetry is the science and technology of obtaining spatial measurement and other geometrical reliable derived products from the photographs. Photogrammetry analysis procedure can range from obtaining the approximate distance, areas and elevation using hard copy, okay, photographs produced product with unsophisticated equipments, that camera or magnifying lens. If there is a blinkometer, okay, or there is a device where you have to keep two photographs and there are light sources and there is a toggle button. So आप दोनों आपको से दोनों images साथ में देखो, you can see overlapping the images and you just toggle the light. Okay, so at a time one light will be focused on one particular image. So that way you will see the difference in the images. You can compare two images also of the same object or same field of view also. So that way you will make a difference to understand if there is any change in the particular location or particular image. That is how you do it. But then the concept has changed because of the digitalization. The geometric concept of generating precise digital elevation models, orthophotos and thematic GIS data. Digital photogrammetry is changing rapidly and forms the basis of the most current photogrammetric operations. Okay, so all the softwares what are now you don't really need to put your eye and brain behind to evaluate the photographs. Okay, now you have a softwares available like Pix4D is there, Scopito is there, Drone Deploy is there. There are at least 10-20 softwares are available, but they are a little bit expensive. You can't get it. You can try them using a trial version and to interpret some data, but that is only valid for somewhere around 25 to 30 days only. Okay, so mapping for aerial photography can take numerous forms, employ either hard or soft copy approaches. Orthophotos combine geometric utility of map with extra real world image formation provided by the photographs. The process of creating orthophoto depends on existence of reliable DEM for the area being mapped. So you have to have that much amount of data. As I told you earlier, we were only having 200 to 500 photos maximum. Again, that used to vary, and those photos were not uniform because they were manually clicked, okay, or manually shoot. Okay, they were not uniform, they were not accurate. Sometimes they were blurry, and all those things were there in those images. But once we have autonomous flying, we have planned the photographs every 2 seconds, every 5 seconds. We used to have a uniform set of data and all things. That's why we were able to create orthophoto of that particular. So you can create really a 3D image of that particular tower in the software. Okay, by putting all the photos from all the angles and providing that GIS data into it or geotagging into it, latitude, longitude, all the information, sites, all that information. Once we fed into the software, it generates it takes all the photos, evaluates, and then basically it creates that image of the tower in the software. Okay, so what is the use of the drone data analysis? So images gathered during mission can be processed using software to sort, organize, and manage. So I will tell you another application. When we capture this data, one was creating that 3D images and all that things. But then again, we need to interpret. Like initially, we were manually doing the. So I mean, we were manually seeing each image on the screen, trying to zoom, trying to find out if there is any defect in that particular photo. Like maybe नट बोल्ट मिस हो रहा है, मेंबर प्लेट नहीं है, मेंबर बार नहीं है, बर्ड नेस्ट फॉर्म हो गया है कॉर्नर में, समथिंग लाइक नो, या फिर इंसुलेटर ब्रेकेज हो गया, चिप्ड हो गया, ब्रोकन हो गया, ऑल दैट थिंग्स, या वायर में कुछ इशू लग रहा है, स्पार्किंग हो गया तो ऑक्सीडाइज हो गया, कलर चेंज इन द वायर, all that things we used to manually see. But then imagine seeing 200 photos or 500 photos. It's a very, very mammoth task. Okay, mammoth task. And then finding from such a high quality image, you have to really zoom to each location and find out. So initially religiously we were trying to do it, but then over later on we found that after doing first 10 hours, we saw it is a very difficult task to do humanly. Again we went back to the another vendor who actually helped us to define the AI ML software for doing this kind of activity. So they built a small program which used to interpret the images and find out those anomalies. So we were initially, when we started building that model, we were initially getting a result around 25 to 30%. As we started inputting more data, fine tuning and all that things over the period of 3 months, we were able to achieve almost 85% success in finding the anomalies out of those. But again, why only 85%? Because sometimes we used to get false anomalies also. Like somewhere bolt जहाँ पे missing है, वहाँ पे actual missing नहीं है, bolt है या नहीं है, maybe होगा, but because of the way the image is captured, because of the shadow, lighting effect, sometimes false images या false data is been interpreted also based on the data what you have shared. So a lot of time there was issues in the photographs also. That's why we were never able to reach up to maybe 100%, maybe not even 95%. We are able to reach using AI ML up to 85%. Classic example I can tell you about, how to understand this AI ML. See, today we are talking about AI ML and image interpretation and all the things. Like if you train a software, to interpret. Like I showed a camera that this is Apple. I showed Apple from all the directions. I got different types of Apple from the market. Okay, and trained my model to show it Apple. Okay, I will try to show it. It will train. Okay, so maybe I would have shown 100 apples to it, and it had data of all 100 apples, and all of a sudden instead of apple I take a tomato similar to apple. Okay, and I hold it, so it may interpret that tomato as apple only because of the color. Okay, maybe because of the texture also. See, we as a human eye, we can interpret between apple and tomato because our brain has been trained like that, but the AI ML software is not trained. So now what did? I brought 100 tomatoes and I fed that data also. So even by feeding that much data, the software is to reach only 75% to 80% of accuracy. Sometimes, like if I have 10 apples in my hand, I want to show, it may be able to recognize apples maybe 7 times, 8 times. Sometimes it is to call even apple as a tomato then now, because now it has a tomato data also. Okay, or sometimes it calls tomato as apple also. So even when I show 10 tomatoes, it may be able to say 6, 7, 8. So I was able to get up to 80%. So same way, see, AI ML can only reach until unless it has that much amount of data. It needs to build, it needs to learn more and more. Like that's why we say that people who use ChatGPT for their work and all this. See, again, even the creators of ChatGPT say that data what is ChatGPT showing may not be accurate. So don't rely on ChatGPT 100%. Okay, so same thing goes for AI and ML. Whatever it is, even you see automation, robotics. See, even whatever today we are talking about the technology and all this, robots are not evolved so much. They still cannot do lot many tasks what as we think or as we human do. Okay, they can process data faster. That is only one capability they have. but that is only what we make them to do it. But if they have to work like us, or they do things like us, or the interpretations what we do or our brain does, that level they cannot still achieve it. Okay, that will still take time for AI to evolve. Okay, so that is what we understood from overall this exercise also, like why we are reaching only up to 85% of accuracy. Sometimes we are getting false errors also, sometimes because of the image capture, the way image is captured, the issue in the image itself also sometimes would be there. When the image was captured, the lighting effect, the shadow effect of the images, all that will give you false images. Okay, so all out of those 100 towers what we did the project, initially we had almost 95 towers having issues. 95 towers there were issues. Over the period of 1 year, when we do this project multiple times, we have taken the images, captures, they have done the rectifications and all that things based on the reports generated every 3 months. Every time we do the survey of the tower and we submit the report and all things, they used to do rectify and all the things. Over the period of year, they got all these towers issues rectified, and by end of probably our project, there were only hardly 5 to 10 towers with minor issues, which was not really our issues, or not issues which could be solved or could be solved by our drone flying and all that things. Okay, so they have reduced all the outages from this 100 towers. That area was not having any time power cut or any breakage or any damage or anything like that. So that way they were able to see that there was no outages, so there was no revenue loss. Okay, the moment you power line is cut, कम से कम 1-2 दिन तक 2-3 दिन तक पावर नहीं रहता था. So you are losing that 3 days of revenue, because no power means no utilization of power, no billing of that particular location, right? So imagine it's not about one particular village or something like that. There could be at least 10-20 villages, and everybody will be not utilizing power for 3 days. So see how much huge loss of revenue would be there. So by utilizing drone and all these things and these proactive measures, they were able to reduce the outages and the issues related to towers and all that things. And that's what they were able to showcase to board, saying that we need to now start using drones for our power line tower monitoring. Okay, same goes for telecom towers also, like where the telecom towers, yeah, gas line pipelines, you have seen very useful use cases. Like I showed you that pipeline, right? Thermal, आप fly कर रहे हो तो आपको कितना amount of data, like you can see the internal structure of the pipeline and figure out where could be a problem or outages can happen. Okay, so that is where it is useful. So you can, if desired data can be turned into 2D or 3D using photogrammetry engines to provide orthomosaic maps, digital surface models, or contour maps. Store and analyzing data from every mission allows end user to, like initially as I told you, right, we used to download the data into the laptops, but then again that laptop was only one person using it. So then later on we moved to the cloud environment. Okay, we deploy all the images into the cloud so that all the people in the office can be utilize that data. So different people were using different images, different or whatever same images or data for doing different reporting, different analyzing and all that things. Okay, so including the progress of the construction site, number of materials stored at the specific location, or incremental degradation of wind turbine. I mean, you can, depending upon what project you are doing, you can interpret. A final report can be generated to share with the stakeholders. So like every 3 months we used to generate whatever the data is, we used to generate a health status of all the towers. Okay, so they were talking about making one portal where all this tower data will be available, and you can see real time the images of the towers. Okay, you can see that 3D image in the software itself, on a portal itself, and you can see it in a 360 degree. You can see the health of the tower, and you can interpret. So whenever we started that project, the health of the tower of all the 100 towers was very bad, but later on, as I said, almost leaving 5 to 10 towers, almost 90 plus towers were in a good healthy conditions. Okay, that is what we were able to present to the board in the last final executive meeting, and that's where they said, okay, we will set up a separate team, separate segment, department which will be doing this kind of activity on regular basis. So they approached backend the board and all the things for funding and procuring drones and setting up this kind of setup. Some people were actually hired also, the local people In fact, they were asking us also. In fact, I left the project in between. I was not there till the end of the project, but still they were actually asking us to join. In fact, they also approached me also for whether you are interested in this. Since it was BR and I don't want to travel outside Bombay or something like that, I said no and all the thing. And then I was interested in doing something more and all the things. And then since my Viva was also aligned at that point in time, so I said no, I want to focus more on training and doing different kind of activities in drone segment and all. Okay, so I declined that offer. So way to view the drone data depending on the software you utilize. You are able to view the data consistently in the following ways. Either you can generate reports including CSV, PDFs, charts, graphics, and tables. Okay, platform analytics including performance figures, orders, missions, inspection, flight, pilots. All these things we were done it. And the most important is return on investment. So whatever that POC you did, you saw the result out of it, right? You saw the benefit, not only from safety but also from the cost revenue perspective also, right? The program result, what you see, data mapping, navigation using graphical interface, navigate your across 2D 3D models, visualize maps, clicks through the images. So that 3D model, what I was saying, was the output from those images what we captured. Okay, so with that we complete the topic introduction to drone data and analysis.